Two.
Good morning, everyone. Today we're going to be going over Chapter 4 of our research book, which is to plan your research project. Just for introductions. Go ahead.
I'm Caitlin.
I'm Ryan.
I'm Nathan.
So what is a research design? The research design is essentially the plan which provides an overall structure of the procedures, data collected, and the data analyzed. The general approach to your research design can include anything from people, things, records, thoughts and ideas, and dynamics and energy, which are all generic research problems. All research problems consist of a methodology or the techniques one uses to collect and analyze data. In your general approach, you should consider the kinds of data required and means of collecting it. It's all about availability, collection, and interpretation. So data tends to be very transient and it's always changing. It's kind of like water because it is volatile and evaporates quickly. Two types of data are primary and secondary data. Primary data is the one closest to the truth. It tends to be the most valid or truth-manifesting kind of data. Secondary data is derived from primary data itself, so that means it is not the truth directly. When planning data collection, you should ask yourself what data are needed. So consider what is needed to resolve the issue at hand. Where are the data located? So what is the geography of where your data is? How is data obtained? Is it through privacy laws, confidentiality agreements, or more? Additionally, what are the limits on the nature of acceptable data? What is the criteria for admissibility of your data? And lastly, how will the data be interpreted? What will you intend to do with the data afterwards? In linking data and research methodology, the methodology must match the nature of the data. The desired data dictate the research method. Two types of data is quantitative and qualitative. Quantitative data tends to explain, predict, and validate. The research is focused and has known variables and established guidelines. The data is representative of a large sample and it is numerical. It tends to be deductive reasoning and consists of statistics and has a scientific style of conveying data. Qualitative data, on the other hand, describes, explains, explores, and interprets. It has a holistic view with unknown variables and flexible guidelines. Textual and image-based data is primarily in qualitative data, and it is informative of a smaller sample. It is usually inductive reasoning, and it is a personal voice with literary style. Therefore, you should try to combine both quantitative and qualitative designs together to create a mixed methods design, which enhances research. In deciding whether to use a quantitative or qualitative approach, you should consider the audience, the nature of the research question, extensiveness of related literature, depth of what you wish to discover, amount of time available to conduct the study, extent to which you are willing to interact with people in your study, your comfort of working with or without much structure, your inferencing abilities, and lastly, your writing skills. Validity is also an important topic in your research. You should consider it as the likelihood that it will yield the accurate, meaningful, and credible results that potentially address the research problem. And there are essentially two, which are internal validity and external validity. Internal validity is the extent to which its design and the data it yields allows the researcher to draw accurate conclusions about cause and effect relationships in the data. Two examples are the Hawthorne effect and novelty effect. The Hawthorne effect is when people change their behavior when they are aware they are being observed. The novelty effect is a tendency for performance to initially improve when new change is instituted due just to increased interest. To eliminate these possible explanations when conducting a study, there are four types, which is 1. A controlled laboratory study, where the experiment is conducted in a laboratory setting, so environmental conditions can be carefully regulated. 2. double-blind studies, where both sides, participants and people administering the interventions, do not know which intervention various participants receive. And 3, unobtrusive measures. People do not know their actions are being recorded. And finally, triangulation, where multiple sources of data are collected in hopes of them converging to support a theory.
So when scientists conduct studies, obviously Caitlin covered the many ways that they can conduct their research. On the left here, they can directly manipulate independent variables in a laboratory setting, or they can just observe and interpret their observations in an unobtrusive manner, kind of like watching through the hallway cameras on Among Us. And as much as we think science is God's gift to the world and a wonderful way to discover how the natural world works, there are limitations. Just because you found something in a study doesn't mean it necessarily will occur outside of a controlled setting. Humans don't live in controlled settings, and we can't be monitored 24/7, 365 days a year. See, and this is where the question of external validity is. And all external validity asks is, how much of your study and the data that you found apply to real-world settings? So there are a couple ways researchers can answer this question and make sure that their data is actually relevant to the real world. One, they can conduct their research in a real world setting. While it will be less controlled, it will be more accurate of real world happenings. Researchers can also make sure that their subjects match the same age, sex, race, and socioeconomic status of the population they are trying to study. Basically make sure that they are representative of the population they're trying to study. And they can also replicate studies in different environments to ensure that their findings can be generalized to a bigger population under different contexts. And there's also many other ways that researchers can gain external validity too. One way is to make sure that there is no bias in their study, or very little bias. Bias is just defined as any tendency that tends to skew results in a study unfairly. Secondly, they have to make sure that when they do their research, acknowledge that there is existing research or circumstances that may either contradict or slightly undermine your research. Do your best to navigate the nuance and acknowledge the limits of your research. Next is to be detailed. So I pulled this really, really complicated paragraph off an NIH study about leukemia. As you can see, the researchers were very, very thorough with the variables that they were studying. And as a researcher, you need to make sure that you cover every single detail or all the relevant details in your study to make sure that it is taken seriously amongst your other colleagues. Lastly, and probably the most obvious, is to spend time in the field. Whether you are a biologist studying salamanders in a river right here, or some sort of scientist trying to find a cure for Parkinson's or cancer and whatnot, you need to make sure that you spend as much time as you can in the field and actually doing the study. Be glued to the microscope, be glued to your net. Whatever it is, research takes time, and you should be willing to put apart time to do research. Now, secondly, we're going to go over how important measurements are. So in science, quantifying your findings accurately will add a layer of objectivity that science needs for its new discoveries. Also, having accurate measurements also helps in replication of your research and peer review, which will help the credibility of your work. So there are different types of measurements that can go. The first is a nominal scale. So nominal scale is basically any survey question or any form of measurement that can be answered in an option. For example, have you been diagnosed with depression? Yes or no. Or it can be other questions such as which breakfast food do you eat most often, cereal or bacon or eggs. Second one is ordinal scales. It's basically rating things on a scale of 1 to 3, or 1 to 10, 1 to 5, 1 to 3. And for example, this question is rate how you procrastinate on your homework. 1, very often. 2, not very often. 3, none at all. The third are interval scales. Now, interval scales are a little complicated, but an interval scale is essentially any measurement that can be lower than 0, essentially. And a really, really good example of this is maybe tracking temperatures across days. And the fourth, and probably the most important out of all these measurements, are ratio scales. Now, ratio scales are basically measures that help you find correlation. And correlational studies are often very, very important in science. For example, correlation is found between self-esteem and depression. Now, if I had to give you a rule of thumb for your study and ensuring that it's externally valid and internally valid, it would just be to stay vigilant. Make sure you go over the details. Double check, triple check, quadruple check your research to ensure that there are no faults in it that would basically undermine your research. Now, arguably, one of your greatest assets as a researcher is also the eyes and perspectives of other researchers, not only your own eyes. Progress is not a one-man sport, or woman's. If you have any trouble at all, reach out to your colleague. They may offer you insight from angles that you may have not considered. And lastly, stay humble. If there is something wrong with your research, own up to it. Admit to your mistakes. Academia and the scientific community is not a place for big egos. Do your research in good faith and ensure that you take into account the feedback from others.
Ethics must also be taken into consideration when one is conducting research. Examples of certain ethical issues that one might want to address are listed here. Are your subjects protected from unnecessary harm or danger, both figurative and literal? Are your subjects willingly participating in your study? Are you protecting your subjects' right to privacy? And are you communicating your results and process with your colleagues honestly? Questions like these must be asked in order to ensure the ethicality of your study. Researchers must be able to protect their subjects and the observers of the study from unnecessary harm. That is, subjects must be protected from harm that does not contribute to the study. For example, a study on pain receptors in humans would have to involve a certain degree of pain, obviously. But subjects should be protected from what one would call torture. You don't want to induce more pain than is necessary for the study. You must also consider vulnerable populations such as the elderly and disabled in your studies to ensure that they are properly represented. Now, on top of preventing unnecessary pain, one might also want to consider offering benefits. Course credit and service hours for students, or even a small monetary incentive may be offered. Counseling or psychiatric care is also an option that can be made available to participants of relevant studies, such as psychiatric studies. Now, the offering of benefits increases the willingness of participants to participate, and therefore it can increase the reliability of your study. Probably the most simple rule of ethicality in studies is that participants should never be coerced into a study. One must ensure that everybody wants to be in the study, and if anybody wants to drop out at any time, they should be allowed to. As a researcher, you also have the responsibility to inform participants of all the relevant information regarding the study beforehand. Some of this information may include the nature and goals of the study, a confirmation that participation is voluntary, a description of the potential risks and discomforts involved in the study, a guarantee of participant confidentiality in the study, and also an offer to provide any further details at any given time, if requested. This information should be provided within an informed consent form, which will also include a place for the participant to sign and date. Now, one's right to privacy should also be protected when participating in a study. Under no circumstances should a study ever be communicated or published in a manner in which it becomes apparent how an individual participant has behaved or responded. You shouldn't be able to tell how a certain specific individual has responded to a study, because that's revealing the participant's private information. Lastly, you need to be honest with how you communicate the process and results of your study with your professional colleagues. Now, for this, there is something called an IRB, which will review your study before you conduct it to ensure that ethicality is maintained. Thank you, and good luck with your research, because God knows we need it.